Hello explorers and welcome to another video. Today we are going to do Advent of Code Day 4. I hope you have a wonderful Saturday morning, and I have prepared here with my favorite beverage, some coffee. And let's just jump right into this. Here we have today's puzzle, and I've already read it in bed. So I'm late to it. You're already almost 1.5 kilometers, almost a mile, below the surface of the ocean, already so deep that you can't see any sunlight. What can you see, however, is a giant squid that is attached itself to the outside of the submarine. Maybe it wants to play bingo. That might be it. Bingo is played in a set of boards that each contains a grid of 5 times 5 of numbers. The numbers are chosen at random, and the chosen number is marked on the board on which it appears. The numbers may not appear on all boards. If all numbers in a row or a column of a board are marked, that board wins. Diagonals don't count. The submarine has a bingo subsystem to help passengers, currently you and the giant squid, pass the time. And it automatically generates a random order which to draw numbers, a random set of boards, your puzzle input, for example. And then we have 3 boards here and a bunch of numbers. After the first 5 numbers are drawn, there are no winners, but the boards are marked as follows. Show the adjacent to each another to save space. So here we have the boards. After the next 6 numbers are drawn, there are still no winners. And then after 24 are drawn, there is a winner up here. And they take that score and sum up all the unmarked numbers on the board. In this case, the sum is 188. Then multiply the sum by the number that was just called on the board, that one, 24, to get the final score. To guarantee a victory against the giant squid, figure out which board will win first. What will your final score be if you have chosen that board? So, I have already prepared the little class here with the input data, the boards, and I also copied some from the earlier here. So input day 3, so now we go to day 4. And here we have the standard line input. So here we need to figure out first if we are on the first line. So int line num is 0. So then we can do line num here. And if line num equals to 0, then we will take the first line, so string numbers, and say that numbers should be equal to that line, and then continue. So the first line is just a bunch of numbers. That's what we want to pick up here. And then we will need a list of boards, and I will make this simple. So we just, or should we actually make a class? Because if we look here, there isn't that many boards. It's not like it's 100 million boards. It's just a couple of them. So let's make some classes here. Bingo board could be a good class, and then boards, new array list. There we go. So we will create that class. Create class bingo board. Can do that. destination package, bingo, perhaps. So we got a bingo board here. And we also need the list class, of course. So import that class. So now we can see here that we got the right, because there is other AVT lists that we don't want. So now we want to figure out if we have a board here. So if we can do board bingo board current board, set that null. So if the line is blank, then we will if the current board is not null, we will take the current board and put that into our boards list. Else, we, or either or, we will take the current board equal to new bingo board and then continue. So that's what we're going to do on each blank line. And as we start with some numbers, then a blank line, then we will have a bingo board here that we can add lines to. So here we can just say current board, add line, and then the line. Then we will handle the rest in the bingo board. So here we go. Now we are in the bingo board. Here we want to have an int array of position or board. You can say new int array, and it should be 5. And then we will have a public bingo board constructor where we go through for int I equals to 0, I less than 5, I plus plus. So here we want to go through the board, I position, and put in the lines of 5. So now we have a bingo board that it's 5 times 5, which means that we don't need to do any math. We could just do a board of 25 if we want as well, and do some math. Yeah, let's do that. Let's do some math. The maths. So, to add a line here, we need to figure out current line here. So that's 0. So when we want to add a line, we will take this line and can we normalize casing or something like that? Split with a regex on any spaces, string line, array, like that. And then for each num in the line array, we just do it system out, print line, and then print the current num just to see that we don't get any extra stuff around it, like that. Don't know why it wanted to tell me something there. So let's do some debugging here. We should have gotten some output. We will go in here, set the first one. Of course. Line num plus plus. And we don't really need the line num either because we will just use it on the first one. Yes, we see here that we actually got just the numbers, which seems fine. We got an ending non-space as well for each, but that's okay, I think. So here we can do another out print line here with some pluses just to see that we are correct in that assumption. No. We sometimes get it. Okay, so let's do a trim then. And see if that will help us to remove those extra lines, because I don't want any space here. I just want the bingo board's numbers here. Yeah, so that looks promising. So now we should be able to take the X position here, then say board current line times 5 plus the X position equals integer parse int num. And then here we will take the current line and add to it. So that should fill up all our boards. Yeah, didn't break down at least. So now we want to have something that can figure out if or add a new number and then figure out if that line is the winning line. And if so, we will calculate that winning. Yeah. So in this case, we want to public boolean add number. Let's do that. And this will be a string, just like that. Or should we do we can do an integer here. So we will handle that in our default function. So now we want first off to go through our board. So int go through the board and see if we can find a number here in our board. If b equals num, then we want to do something. And we also want to keep track of the position, so we know where on the board it actually is. So let's see now. If they are equal, then I want to take the board position and set it to the minus number. And why do I do that? Well, in this case, we have only positive numbers in our input data. And I might shoot myself in the foot here by marking the board with negative numbers. But I thought that if I can mark myself on the board with negative numbers, then I can just check if all the numbers in a row or a column are negative, and then I will know if I have a valid bingo. So now that we have figured out that was the position, we will break here. So now we know the position of the number. Now we want to check the line that was on, and we also want to check the column that it was on. And in this case, I want to do some modulus operation in order to figure this out. So I guess that column would be position modulus 5. So we get the remainder there. And the row could be position divided by 5. So that might be the correct solution. I don't know if we need to do anything else with this. So if we have 25, which we never will, we will have 5. If we have 24, it probably become 4. But to be sure, we could do double and then math floor. Floor div. That's much easier. Let's do that. This sounds so much more fun. So now we get the row and the column. And for int I, and less than 5, I plus. So let's try the row first. So board row times 5 plus I if, yeah, okay. Count, and then we will take count is equal to board. If this is negative, then we will have 1 here, else 0. So that will check the row, and then we can do the same for column. So if count equals to 5, we will have a winner. And then we can just return true here. And the same goes here. Return true. Else we will return false. So in this add number function, we will add a number first. We will figure out which row and column that number was added. We will count through the row and see if we have 5 numbers on that row that is negative, which means that we have marked them all. If so, we will return true. Condition 5 is always false. Yeah, you are right. So nice when the IDE tells you that you have screwed up. And then we will do the same for the column and return true if we find it. And if we have found it, we need to calculate all the numbers that are not negative. So we want to have a different function here. Public int calc winning board, and then we can have this last num here, and we will, for each, we will go through the full board and count. We will add all the numbers, so board I. If board I is larger than 0, then we will take count and add that board value here, and then we will return count times last num. So that's pretty much my calculation here. So after here we will do a for loop on this num, and we have the numbers. We will split those with the comma and let's see, string numbers, string num. What? We have numbers. What's the problem? Might not have been initialized. Okay. Then let's do that. And here we will take int num int integer parse int num. So now we will have the number if the board. So we need to do for boards. If the board, bingo board, if the bingo board, when we add a number, if that's true, then we will take the board and calculate the winning board with that number and print that out, and then break. We can do system exit with 0, and then we will do a system exit with -1 because we didn't find any board. So let's see if this will work. Index 25 for a bound of 25 in add numbers. Okay. So we have a row times 5 plus I. So when did that end up being 5? So let's go here and see. Row equals to 5. When did that happen? Should not be possible, right? But it is. Yeah, and we're back. So of course it could be that we are ending up at 25 or higher because there wasn't anything on the board. So let's say if position is larger than 24, then we will just return false because then we didn't put anything on the board. So that's not a reasonable number. So let's try this again and see if we get anything. We got 0. So no, we weren't able to do anything here. So that's interesting. Let's do some more. Let's see here. String line. it ends up there. So let's see how the boards look after we've added all the lines. We have 2 bingo boards. Is that expected? No, it's expected to have 3 bingo boards. So why didn't we add the last bingo board? That's because we didn't have any. So here, if current bingo board is not null, we will add that as well. So boards add current bingo board. So that's why we didn't have 3 bingo boards. And the third bingo board was the one that was winning. So they did us a solid there by actually not having any of the first 2 to be the winning board. So let's see if we can just run this. We still get 0. Okay. And if we do this again and go down here, add number. If we add number to the first board, second board, and the third board, what happened to the boards? Do we have any boards? We have 1 board that has a -7. But the boards look really weird, right? So I think our add line is weird, right? Let's see here. Current board. So here we have the boards. So that board is not correct at all. So let's see where we add a line. So we get the first line here. And we get the first line array, which is a couple of numbers, where one of the numbers are 0, which is correct. And then we will go through here. And current line should be 0. So 22. Oh, we don't increase X. Yeah, that's why. Let's do that. There we had it. So the result was 4,512, which is the correct number. So debugging is the thing. If we go back here and do a switcheroo here, we will change up how we read our data, which we usually do. So we read the lines from the input data instead. What do we get then? We got 63,552. We put that in, we get, you get a gold star, I get a gold star, everybody gets a gold star. We solved the first one. So now we hope that we haven't shot ourselves in the foot with the second part here. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing is to figure out which board will win last and choose that one. That way, no matter which boards it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is actually called, and it's the middle column is completely marked. If there were to keep playing until this point, the second board would have the sum of unmarked equal to 148 for the final score of 148 times 13. Figure out which board will win last. Once it wins, that should be its final score. So we haven't really shot ourselves in the foot. We have actually a solution that could work with this. Because if we have a winning board, when we add a number, then that will be our current board and our current number. But we will not calculate the result. So we can just say here we have bingo board, winning board, and that should be null. So here we will just say that the winning board will be B, and we also need to keep the winning number. Let's set that to 0, and the winning number should be num int here. And if we have a winning board here, if winning board is not equal to null, which it shouldn't be, we will take the winning board and calculate the winning board with the winning number. So that's our strategy here. Let's go to the test data here first and see what the number will be. It didn't calculate it, or it did calculate it, but it didn't print it because we didn't print it. So let's try it again. 0, so that's not good. So let's see here. The winning board, which board is that? This board is 22. Starts with 22. So it was the first board. But we don't want to continue marking numbers. Okay. So what they are saying is the last winning board, so when we don't have any boards that are winning anymore, that's the board that we want. So we can't just keep the winning board, we need to keep all the boards that has won. And so the bingo board here, we will have something called a winning board. Let's see. Perhaps we can just say number of winning boards equal to 0. Number of winning boards if number of winning boards are equal to boards and the size of those, then we should break to outer loop. So we should break to the outer loop, and then we will have the same calculation here. So if we have all boards have 1, then that will be our endpoint here. So let's see if that works. Then we get 1092 as a result, and that's not correct. But it was better at least. So let's see here. The first winning board is board number 3, it should be. Let's see here. Winning board seems to be number 3, yes. So then we have a number of winning boards, and that's false. So let's continue. Then we have another winning board, and that should be number 1 then, which it is. And we don't have as many. And here we have okay, so now we get the winning board number 1 again. So the first board 1 again. So we need to keep track of if a board has 1. Has 1 equal to false. So in the case that it wins, we say equal to true. Might not be the best way to do this, but if it has already 1, then if has 1, then return false. So now it can't win twice. We still don't get the right value. So we have a winning board here. And we have a winning board again. So now we should have the third board as a winning board. 3. Yeah, so that's the third board. And the winning number is 12, which is not correct. The winning number should be 13. Now that's strange. Winning number 12, winning boards 3. So do we have a winning line or row here? Let's see. We don't have a winning line, I believe. Yeah, we have a winning line. It's the last line. With the number 14, 21, 16, 12, and 6. 14, 21. 14, 21, 16, 12, and 6. And 13 was called earlier, but then 18 had not been called yet. So 7. So I think that that should be the winning number for this board. So we have 0. Oh, we have 0. That's no good. And so in the case of 0, we need to handle that specific case as well. Oh, They were ugly when it comes to that. So when it comes to 0, if num is larger than 0, then we do that, else the board position should be, let's say, integer max value. Let's go for that. so we know that that one was 0. So there we were a bit lucky that the first one worked then. So let's see here. Let's debug this again. And we have 1 winning board, 2 winning boards, and then we still say that it should be 12. So let's look at the board here. Oh, minus max int, of course. Or should it be min value? Yeah, that's what we want. See if that works. Yeah, that looks better. 1924. And that's what we got. So I didn't handle the 0 number case. That's a gotcha for real. So let's go back to the real data here and see if we have solved something. Let's run it and see what number we get. 9020. Let's try it. 9020. Yes! You get a gold star. I get a gold star. Everybody got the gold star. So, in this little trial today, we did a lot of debugging because we weren't really working things out the correct way. So what we wanted to do here was, first off, have a bunch of boards. We have a bunch of bingo boards, and then we go through each line here, and if it's the first line, we know that's all the numbers that we want to call out later for our bingo tournament. And then if we have a blank line, which is often the first line after that command line, then we will create the board. So we have a current board, and then we will add lines to it. And when we're done, we will add the last board, so we have that. Then we need to keep track on the winning boards. So if we have a winning board and a winning number, and then we will figure out how many winning boards we have, because we want to take the last available winning board just so the squid have the best chance. So we go through here and get the numbers, go through each board, add the numbers to the board. If we figure out that this number is a winning board, then we will go in and set the winning board and the number of winning boards. And if all boards have 1 already, we will jump out of this outer loop and present our results, where we will calculate the winning board. And calculating the winning board is just going through and calculate all numbers that are not negative, because I use the negative mark to set that a number is not is already taken. So we count those up and then time that with the last number that we send in here to this function. And adding a line is very simple, going through each number and just putting it in the right position in the current board. Then we have this little boolean here that checks that we don't add more values to a board that has already won. So we skip the winning boards here, and then we will go to position, and then we will add a value to the board and figure out which position we added the number to. And that position in turn, we will check that it's not more than 24, which means that it is on the actual board. If we have 25, we have gone through the full loop, but we haven't found any numbers. So it needs to be 24 or less. Then we will calculate the column and row of the specific value here, and we use a new function for me, floor div, so we will actually get the division with floor built in, which is really nice. And then I will go through and count each row and count the row and see if the row that we put in a number into, is that a winning row? And if we have 5 numbers that is already taken, then it's a winning row, so we will return true and set it, this board has won. Otherwise, we'll go through each column and the winning column and see if we have 5 numbers in the winning column, or the column that we put a number into. And if so, we'll return true here and has won set to true as well. Otherwise, we haven't found any winning numbers on this board yet, and we will continue the process. So this was day 4, where we went through and did a lot of trial and error and figured out how to play bingo with a giant squid. And hopefully the giant squid has won and left our little submarine to us. I hope that you liked this video. I hope that you learned something today. If you have any comments or suggestion or want to show me your code, leave a comment in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.